Hello and welcome to the Cyber One YouTube channel. My name is Ray, and in this video, Fred's Left Arm Part 12, we're going to look at the TCA 9548A I2C multiplexer. Okay, so this is a cool little device designed for when you have an I2C bus and you have multiple sensors or I/O devices where you have a limited number of addresses available on those devices. An example would be the MPU 6050, where it can only be configured for one of two addresses. By using one of these devices, you can have up to 8 devices or 8 I2C buses all connected together. And that allows something like the MPU 6050, where you can only have 2. It now multiplies it by 8 and gives you a total of 16 that you can potentially have on the bus. Now, if you've been following along the series of Fred's Left Hand, you'll know that I mounted an MPU 6050 in the palm. I plan to also put one in the bicep, so there's 2 devices. If I want to do the same thing on the right arm, then there's another 2 MPU 6050s. I already have an MPU 6050 in Fred's head, and there's also another one in his chest. So there's a total of 6 MPU 6050s, and I can only address 2 of them. So what we can do is we can actually set this up to have addresses down, or split this up, multiplex down, so we can have extra MPU 6050s. What we're going to do to make it a little bit easier, I'm going to use this little bit of experimenter's board, which I picked up from JCar Electronics a while back. And we're going to mount that onto that board. But because I want to be able to change things around, because Fred is always being re-engineered, we're going to use these headers onto this board, and we're going to use these pins onto the back of this so we can just plug it in. I'm also going to put pins in for the VN, the ground, and the SDA and SCL lines. And I'll then connect this back to the Raspberry Pi 3 I have sitting over here. This Raspberry Pi 3 is running Fred Online at this stage. I picked that up from JCar somewhere. I don't have a record of it anymore. That I know I picked it from JCar because I unwrapped it this morning. And these connectors I picked up from Benny International on eBay. So, alright, let's get started with this. So these do come with the headers already, but not installed. So I'm just going to cut this. I have misplaced those headers because I use them on everything. Now, to help make sure that they are all aligned okay, I'm just going to drop these into some of the holes here. That'll make them stay nice and straight. And then I'll fire up soldering iron. Okay, so that's those ones soldered up, and that's the easy part. Now, when you cut these down, you will lose one of these pins. Can't be avoided, unfortunately, because we've got to cut it right on one of the pins to break it out. Okay, so now we can put this into our board. Now, this is going to not line up dead middle. They never do for some reason. Actually, it will line up middle. So our pins will come out. You can see these. So you can see these pins are on the outside edge here and on the outside edge here. So all of our wire is going to be looping from these inner pins out to wherever we need them to go. That'll work. I used the same sort of board on Fred's chest in that video. If you haven't seen that video, I'll see if I can remember to put a link up in this corner. Might just move that light a little bit. They look all right. Okay, so now we can decide which way round we want this to go. So on this printed circuit board, if it'll focus, you can see I've got V in at the top left, then ground, then SDA, then SCL. So SDA is serial data and the SCL is serial clock. We've got a reset line and then we've got 3 address lines. Now the address lines is important. You can have quite a number of these devices on a single I2C bus. With one line, you can add a second device on with 2. You multiply that by 2 again, so 4, then 8. So we've got 1, 2, 4. We can have up to 8 devices on this bus. And they do start at address 70 hex and go up from there. So it is possible to multiplex this down to other multiplexers. And if you know what you're doing, you can also put these after this on a multiplex address and have up to 8 of those down there. So you can have quite a significant number of these things on there. But keep a mind on what addresses you're using. So this starts at 70, but with the PCA 9685, which I have over here, they have 2 addresses on them. They have the address that's programmed by the address jumpers on this side, but they also have a broadcast address, so you can send a command to all of them at once. And that broadcast address or command address is on 70 hex. So what we really need to do is set this for at least 71 so that we don't get a conflict. All right, so to do that, looking at the data sheet, we need these 3 lines pulled either high or low. And I will bring up the data sheet and show it to you as part of this video. So address input 0, 1 and 2 connects directly to VCC or ground. Okay, so when all 3 analog inputs are set to 0 or ground, it's at address 70. So I want to tie 2 of these to ground, A1 and A2 to ground, and I want to tie A0 to VCC. Now in this case, VCC is that V in. So we're going to put a jumper from there across and we're going to tie the grounds together. Now on the back of this board, you'll see there's 2 copper strips. And what I'm going to do is I'm going to make one of those copper strips is a ground, and I'm going to tie the V in to that ground. Oh, sorry, the ground from over here. So it's over there. I'll tie it to this strip here. So that'll be this connect. Yeah, that connection there. And that'll allow me to then connect whatever I need to ground, and that'll be 2 of them. I do need to connect VCC across as well, but I also need to be able to connect on a plug like this. So what I'm going to do is get another little bit of the strip, cut 4 off and put those in up here. And that'll be my jumper for connecting it to, put them on this side I think. That'll give me somewhere to plug these onto. Just to give it a little bit more height while I'm working on this. That'll keep it engaged in the board. So that's done now. I can now look at wiring those through. So let's make the top one VCC. Let's just run down V in, ground, SDA and SCL. That'll make life easy for us and easy to set up. So I need a little bit of hookup wire to do that, so I'm just going to grab that now. We'll use brown for our V in. So essentially these will line up with these pins over here. So we want, let's mark this easier anyway. So that's V in. We want to put a link between there and that bus there. We've got SDA, SCL, which need to be linked up to here as well. We need to link that down to here as well. This one we need to link to here, and this one we need to link to here. So that's pretty straightforward. Then we've got reset, which I'm not going to touch at this stage. I may run that back to the microcontroller yet, or the Raspberry Pi, as the case may be. So 1, 2, 3, 4, that's reset there, and that's A0, A1, A2. So A0 I need to connect back to here as well. So let's get our next bit of wire ready. This will be run on the inside, so we can run it through, a little bit to cut off and then strip. Now, as long as all our grounds are joined together, we can actually use different voltage supplies on these pins. That's going by the data sheet for this. So we can run anything from, I think it's 1.8 volt on the I2C bus up to 5 volt on the I2C bus. And we're going to run on at least one of those 5 volt, others will run 3.3 volt. Now coming in from the Raspberry Pi it'll be 3.3 volt. If it's coming from an Arduino it will be 5 volt. I've already soldered that. Alright, so that's all of the positives that I need. Let's move on to our grounds. And we're going to have a few of these. So from that pin we're going to run around and onto the second pin of this. I'll look that up, poke this wire through here, and now I'm going to fold it down this way, like that, and I'm going to solder it to the bus and onto the ground. If I was smart, I would have done this in the first place and then taken it round to the input supply. But I never said I was smart, because now I can trim this off. If you remember, that was A0. So this is going to be A1, and we want to tie A1 to ground. And just to make it clear, we're going to do it exactly the same way for A2. So we've now got it fully addressed. Let's get some other colour wires and we'll do the SDA and SCL. But I'm going to use orange and yellow. Now there isn't actually a convention for the colouring on these, so we can use whatever colour scheme we like. In this case I'm going to use yellow for SDA. So it's going to run from here, which is the third pin down, and then run around to our third pin here. Alright, so this plug now has all the wires we need to connect it back to a Raspberry Pi. So when we plug this into here, this chip will be powered from the Raspberry Pi board or the Arduino board if you choose to use the Arduino, and it will get the I2C from there. We've addressed it. The reset, I believe, is held high normally, and it does have a section in the data sheet on power on reset. So when power is applied to the VCC pin, an internal power on reset holds the TCA 9548A in a reset condition until VCC has reached its VPORR, so that's power on operation. At this point the reset condition is released and the TCA 9548A registers and I2C state machines are initialized to their default states, all zeros causing all channels to be deselected. Thereafter VCC must be lowered below VPORF to reset the device. Now it does have a list of voltages in the data sheet on what those two voltages are. Now if I look up the data sheet, it will have those voltages listed. And I'll try and pull those out of the data sheet and put them on the screen for you, or at least write them up on the screen. And there's a lot of information in the data sheet. So power, PRORR, so power on reset voltage rising, must be in excess of 1.2 to 1.5 volts. So typically 1.2 volts it'll actually complete its reset. When it drops below 1 volt, it will go into reset. So this will run on 1.8 volt and above. 1.65. So any voltage exceeding 1.65 volt to 5.5 volt is treated as a valid signal for SDA. Anything below 0.6 or 0.4 volt is considered to be a logic low. Now, to understand the I2C bus, you need to remember that there should be a resistor connecting both the SDA and the SCL to VCC. So that's the supply voltage. So in the case of a Raspberry Pi, that would be 5 volt. Sorry, a Raspberry Pi would be 3.3 volt. In the case of an Arduino, that would be 5 volt. There are some microcontrollers out there that will run as low as 1.8 volt. So if you tied it to 1.8 volt, this will still work. The way these devices communicate is they use an open collector transistor, and that transistor will pull the SDA and or SCL lines down to ground. The SCL line is always controlled by the master. The SDA will be controlled either by the master or the slave, and in this case the slave will respond in request to a master command, or in response to a master command. So we can actually have these other pins connected to say 5 volt, while the microcontroller or CPU controller runs 3.3 volt. And this device will work still. It's quite happy to run multiple voltages. All right, so we've got our first bit set up, and next one is to work out our SDO and SCO, which is our first multiplex bus. And on that we need to connect up some, we've got 4 pins to worry about. We've got ground, we've got VCC, SD0, and the SDA and the SCL. And we need to feed, if we look at it the way we're running, I think what we'll do is channel 0 will feed back up to the head. Channel 1 we're going to feed to the devices inside the body of the robot. Channel 2 will send to the left arm, and channel 3 will send to the right arm, and that leaves me with channels 4, 5, 6 and 7 that I can use elsewhere if I need to down the track. And I'm thinking along the lines of motorized legs at some stage down the track. So what we'll need to do is actually set up some connectors for it. So in the case of the one going back up to the head, 4 pins will be enough. In the case of the one going to the body, again 4 pins will be enough. For the one going to the left arm and the right arm, we're going to need a few more pins. So if you remember the layout for the left arm, we've got 6 wires going, 12 wires going out in our ribbon, and it's a ribbon cable that looks like this. The top 3 and the bottom 3 are used for power. So we've got 6 wires to worry about. Now, 2 of those wires are not really used at this stage. One will be set up to connect to ground for disabling the PCA 9685s, and I'll probably set that up somewhere else, so I'll leave that pin for now. And the other one is for a different voltage if we need to supply a different voltage. So for now, that one can be left as well. So really, when it comes down to it, we only need to have 4 wires for the left arm and on this, and 4 for the right arm. So we're going to need a total of 4 sets of headers of 4 pins each. So let's start setting them up. I think what we might do is put a gap in there so it's easy to identify them. And I'm going to put a texter on this first one, texter mark, to show that this is our master. This will go to the master controller wherever we locate it. That could be in the head or it could be on the back. When I say it could be on the back, an example would be with this. So this is a very dusty LCD display. It's not a very high resolution display with a Raspberry Pi. In this case, it's a Raspberry Pi 3 on the back. That could be a Raspberry Pi 4, and we could connect this back and use the I2C bus off it. And then we could use a secondary Raspberry Pi 4 in the head to do computer vision, OpenCV. But that's getting a little bit ahead at this stage. Right, so the one that I want to worry about the most now is the ground. So that's going to be the second pin going that way, and we're going to tie it to that ground bus. What I've made, there's a way I can do this and make it easy for myself. So since this is going to be a ground as well, what I can do is tie that over, and then I can bring that round and into that ground pin up here, and then bring the other ground pin onto the spare terminal in there. Let's just tin this first. Because the I2C bus does ground the communication wires as part of the protocol for communicating, we do need to make sure we're using a common ground. Let's run our clock wire, sorry, our data wire. Alright, so when we're looking at this device, SDO will go to there from 1, 2, 3, 4, from that pin there. Now I just had a thought as I was starting to wire this one up. If I add one in here now, I can do the ground loop for it all the way through, leaving in a spare loop for when I want to do another one later on. And that could be used for the one down the bottom, or it could be used to communicate to some other device in the chest even. So I might just mount that in place, do the ground, and then wire up the SDAs. So I've got to work out what I'm doing with the active supply, or the VCC power for the these connectors out across here. That's all the data lines I'm going to do today anyway. I do at some stage need to seriously consider about the other ones. But let's do the clock lines now, since they're just as important. I haven't wired this one up at all for the SDA or SCL. I'll come back and do that shortly. Let's get this line in that I forgot. So that leaves us with just the power to sort out. So there's 3.3 volt probably from here, which is our main input, if you remember correctly. But we may want a mix of 3.3 and 5 volt going out. And I will need to tidy these wires up a little bit before I'm finished. There's quite a few of those now. We can probably put this in now, as long as we put it in the right way. Cool. Alright, so that's 0, 1, 2. No, it's not. 0, 1, 2, 3, 4. Because I forgot about the this one when I was wiring up. So when I said was going to the head, and that's 3.3 volts, so we can connect it back to this one if we wanted to. And I think I might just do that. Okay, so what I've done is I've gone into, if you look at the pattern on these, you've got these blocks here of 3 across. So up here there is a block of 3 across here, and I've gone into the middle one and then bridged across onto our VCC terminal, and then that's come back to the VCC over here. So I've got VCC on here, but I've got these 2 spare pins with VCC on them as well. I'm going to bridge that one across and onto here. That leaves me with 1 spare should I need it down the track. And this will be 3.3 volt. Because I'm using a Raspberry Pi. Okay, so I'm going to put 2 pins in here, call it my 5 volt supply. At the very least, I'm going to use those for the arms. Now, since I messed up a little bit, so that's 0, 1, 2, 3, and then 4, I'm going to make these 2 connected to this. Make the bottom side there ground, so I'll go from there, run it round and up to this one. Okay, so I looped that across and picked up this group of 3 linked together here. So I've got 2 points that I can connect onto 5 volt down the track if I need to. This one I haven't actually connected to anything as far as 5 volt goes yet. I could go to either the 3.3 volt, there's a connection point below here I could jump onto, or I could connect it up to here and get the 5 volt. That'll do for this bit anyway. So I've connected all my power. I will need to fit terminals on, or connectors onto the end of the ribbon cables, and make up ones for the Raspberry Pi. There is a service for this on the Raspberry Pi. I've got it connected now, and I will test this out. This is configured for address 71 hex instead of the default 70, and that's because I didn't want to have it on 70 when I've got so many of these devices all sharing 70 as a broadcast address. Even if my Robot Lab's not using it, these might respond in an unpredictable manner when we're trying to address this. So let's just leave it alone. So when I do install this into the back of Fred, I've got this got to be wired up to the head. This has got to come from the master Raspberry Pi, which currently is in the head, so I'll have to do that as well. This one here will get connected to the PCA 9685 that's currently in his back, and these two will get connected to the left and right arms respectively. And then I may even put a separate XL4005 switch mode pass plane configured for 5 volt to supply that as a separate item. They'll supply up to 5 amps. So I'll leave that for the next video because this one's getting long already. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. To be notified when these videos come out, don't forget to click on that subscribe and ring that notification bell. If you'd like to help the channel further, I do have a Patreon account. There is a link in the description below. I'd like to thank my long-term Patreons, Go Lucky and Lorenz Berger, both VIPs, and my Builder Patreon, Elmorales45. If you have any questions at all, feel free to leave a comment down below or join us on Discord, and you can even talk to Fred online over here. There's a link to the Discord channel in the description below, and we'll see you in the next video.